Hello friends, I am Professor Manoj Kundare. I welcome you all in this electronics YouTube channel. In this video, we are going to run the first practical of SYBSC Computer Science Electronics Semester 3. The name of the subject is Microcontroller Architecture and Programming, and the name of the experiment is the arithmetic, logical, and code conversion problems using assembly language programming. For this practical, we require this Keil software. So let's start our today's practical. First of all, double click on the Keil Microvision 5 icon on the desktop. After double click, the software will open. If the project is already open, then go to the project tab and select close project. Then again go to the project and select new microvision project. Here the create new project window will appear. In this window we have to suggest a file name to this project. We can give any name like arith practical. Okay. Note here that the file name do not contain any extension like .asm or .c. Here, simply give the file name and select Save. Now, the select device for target 1 window will appear. Here, we have to give the 8051 microcontroller chip. In this search tab, enter your controller. Here in this video we are going to perform programming on 8089C51 microchip. So enter here 8089C51, then select it and select OK. Now the startup window will open. We can select it yes or no. In this practical, we do not require this startup window or this startup file, hence select no. Now we can see here the project name appears arith practical, and the target one is created for this project. After clicking this plus icon, we get source group 1. Okay. Now go to the file tab and select new file. Here we have to write our program. We can write here the program in C language or in assembly language. In this practical, we are going to perform the assembly language programming. So let's start our first program, the assembly language program for addition. Assembly language program for addition. Now let's start the algorithm for this program. Our first program is for addition. Okay. Now if we want to perform the addition of two data bytes like 42H plus 12H. Okay. Now we know that the addition of 42H plus 12H is 54H. Now we can write the program steps for the above addition. So the algorithm is the first step for the algorithm is load the first byte into the accumulator register. Load the first data byte into the accumulator register. That means register A equal to 42H. Now, our next step is load this second data byte into the register B. Load the second data byte into the B register. That means B is equal to 12H. Okay. Now, our third step is addition. For this addition, we can use a double D add or a double D C. A double D add means the simple addition without carry, and a double D C means addition with carry. Then the result of the addition will be stored in the accumulator. Okay. The final result of the addition will be stored in accumulator register. Hence, move, move it to any memory location. Okay, that means the result of the addition 54H is stored in the accumulator register. Then move this result into the memory location. Select, suppose the memory location is 50H. Move the result to the 50H memory location. Let's see once again. If we want to perform the addition of two data bytes, 42H and 12H, we know that 42H plus 12H, the result is 54H. Then the algorithm is very simple. Load the first data byte, that means 42H, into the accumulator register. That means A equal to 42H. Then load the second data bytes into the register B, that means B equal to 12H. Perform the addition operation with A double D add or A double D C addition with carry. Then the final result of the addition, that means 54H, will be stored into the accumulator. Then move this result into the memory location 50H. Okay. So let's start our program. First of all, set origin org 00H. Then the first instruction is that load the first data byte into the accumulator register. Hence, we use here instruction move a comma. We have the value, hence we use the immediate sign, immediate data or hash sign immediately 42H. Okay. The next instruction is that move the second data byte into the register B. That means move register B, comma, and the value is 12H. Then add A with B, hence use A double D, add A comma B. The result will be stored into the accumulator, hence move this result to any memory location. We use here memory location 50H, comma A. Okay. Then these are our program steps or the instruction. Now save this file. Hence go to the file tab and click on the save. Okay. Now we can give any name to this file. Our project name is arith practical. So arith practical. Okay. You can give any name to this, but our project name is arithmetic practical, arith practical. Hence, I give the same name to it. Now, you have to save this file with the extension. If the program is in C language, then save it with .c. Okay, but our program is in assembly language, hence save it with .asm. Okay, note here that your program is in assembly language, hence save the file with .asm extension. I hope you all understand. Now save it. Okay. After save, we can see the colors are different to the different parts. For mnemonics, we get blue color. For register, we get green color. And for the values, we get red color. I hope you all understand. Then go to the source group and right click on the source group. Let's see once again. Go to the source group, right click on it and select manage project items. Here we have tab add files and we have to add our files here. Okay, then click on the add files. This window add files to the group source group 1 will appear. Our file is arithpractical.asm. Okay, here this file is not available. So go to the files of the type, select this drop down and select ASM source file. Okay. Then we get here arithpr.asm file. Click on it, select add and then close. We can see here the file is appeared arithpr.asm. Click on it and then OK. After selecting OK, we get this file is in source group. Let's see. Click on OK. Then click on this plus icon and we get arithpr.asm file here. Okay, I hope you all understand these steps. Now go to the project window, select options for target. Here we have to select the crystal frequency. Generally, for 8051 microcontroller, we use 12 megahertz crystal. Hence, type here 12. Okay, that means we give frequency 12 megahertz. Then go to the output tab and select create hex file. Here, note here that if we want to perform interfacing with the controller, that means if we want to perform stepper motor interfacing with the controller or LCD interfacing with the controller, then we require a hex file. After clicking this icon, we get the hex file. But in this practical, we does not require any hex file. Hence, uncheck it and select OK. Okay. Now again go to the project tab and select build target. Here after this step we get the errors. If the errors are 0, then our program is ready to execute. Here we get 0 error but 1 warning. Here one warning is for end statement. We can see this warning here. After scrolling we get warning ever missing end statement. If we give it end statement, then save again. Go to the project, select build target. Now we zero warning. That means our program is ready to execute. Then again go to the project window and select rebuild all target files. Zero error, zero warning. That means Our program is ready to execute. Now go to this debug tab and select start stop debug session. Okay. After we select OK, we get this output window. Okay, here we can see the different registers are here. Register R0, these are the general purpose register R0, R1, R2, R3, R4 up to R7. And these are the special function registers. Register A, that means accumulator. Register B, that means register B. SP, stack pointer register. PSW register are here. Okay. Now we are going to run our program. Our program is the addition of 42H plus 12H. The result is 54H. Okay. Here we require 50H memory location. So select memory window. For selection of memory window, click here. Okay. Select memory 1. Again, you can go here and select memory 1. You get memory 1. We require 50H memory location. So, in address tab or address bar, type D colon. We require 50H, 50H. Then enter. Okay. Now, we get here this location is 50H. Okay. After the execution of the program, the result is stored into the 50H location. We know that the result is 54H. Hence, to run this practical, again go to the debug tab and select run. Okay. We can see here the result is appeared at the 50H memory location. If we want to perform the step-by-step execution, then we can select this icon. Okay. So let's see the step-by-step execution. Again, go to the debug tab and select start stop debug. Now, this time we want to see the step-by-step execution. Hence, we can click this icon. Okay. This instruction is that move a comma hash 42H. That means after this instruction, we get accumulator equal to 42H. That means 42H is loaded into this accumulator. We can see here the value of accumulator is 00H. After execution of this instruction, we get accumulator is equal to 42H. Let's see. Click this icon. We get here accumulator is equal to 0 cross 42. This 42H is loaded into the accumulator. Similarly, after this instruction, the 12H is loaded into the register B. Now the value is 00H. After execution, B is equal to 12H. Click on this icon and see B is equal to 12H. Now after the addition A double D add A with B, the result will be stored into the accumulator. The result of the addition is 54H and it will store into the accumulator. That means here we get 54H. Let's see, we get 54H. Now move this result into the 50H memory location. Currently, the 50H memory location has the value 00H. After the execution of this instruction, 50H will contain 54H. Okay, click here. We can see here we get 54H. I hope you all understand the simple program for the addition. Okay, now let's see the next program. Let's see the next program, assembly language program for subtraction. Okay, then first of all, Assign these instructions as comment by giving double slash at the starting of the instruction. Now, these instructions are not executed. Here, we can remove end statement. Okay. Now, these are the comments. These are not instruction. Okay. Now, we have set org at 00h. First of all, see the algorithm for the subtraction. Our second program is for subtraction. Okay. So, if we want to perform subtraction of 42h minus 12h, we know that 42h minus 12h, the result is 30h. The algorithm for the program is the first step is same, load the first data byte into the accumulator register. That means load 42h into the accumulator. The first step is same. The second step is also same. Load the second data byte into the register B. Okay. Now our third step is perform subtraction. For this subtraction, we can use SUBB subtraction with for, and next the final result of the subtraction will be stored in the accumulator register as it is. The final result of the subtraction will be stored in the accumulator register. Hence, move it to any memory location. For addition, we use 50h. For subtraction, let's use 52h. Okay. I hope you all understand the simple algorithm for the subtraction of two data bytes. Now, write the instruction for this algorithm. First of all, set org 00h. Now, load first data byte into the accumulator register. For this, type move a comma immediate 42h. Then second is move b comma immediate 12h. Then subtract a from b, SUBB a comma b. Then move the result of the subtraction into the memory location. We in algorithm we use 52h memory location. Hence move 52h comma a. Okay, and at last end statement. Okay. Now you can save this program by clicking here file tab and save, or you can simply enter Control yes or click this icon save. Okay, here we already saved this file with .asm extension, hence no need to give again the .asm or .c extension. Just click this icon or press Ctrl yes. Our program is saved. Now go to the project window and select build target. We get zero warning. Again, go to the project window and select rebuild all target files. Zero and zero warning. That means our program is ready to execute. So, to run this program, go to this debug tab, select start stop debug session. Click OK. The output window will appear. Okay. Now we can see here these instructions are not executed because we give double slash. Due to this, this now becomes the comments. These are the instruction to be executed. Okay, we are going to see the step-by-step execution. Hence, use this icon. Okay. Now, after the execution of this instruction, 42H will be loaded into the accumulator register. Okay. Currently, accumulator has value 00H. After this execution, accumulator will contain 42H. Let's see. Okay. Now, move B comma hash 12H. After execution of this instruction, register B will contain here 12H. Okay. Now, the subtraction of A and B gives us result 30H, and the final result is stored into the accumulator. That means A will contain 30H. Okay. Now move this result into the 52H memory location. We can type here 52H, or we can see this is 50H, this is 51, and this is 52. Here we get the final result 52H. Let's see. Okay, we get the final result 30H into the 52H memory location. I hope you all understand the simple assembly language program for the subtraction. Now, let's see the assembly language program for multiplication. Our next program is assembly language program for multiplication. Okay, let's see algorithm for multiplication first. Third is multiplication. Okay, suppose we want to perform the multiplication of two data bytes like 65H into 32H. We know the result of 65H and 32H is 13BA 13BAH. Here, the result of the multiplication is very large. 65H into 32H. The result is 13BAH. We know that the final result of any operation is stored into the accumulator register. But this result is very large. Our accumulator is of 8 bit, so it cannot handle this large result. For this purpose, register B is always used with register A during multiplication and division operation. This result is divided into two parts: higher byte, that means 13, and the lower byte, that means BA. The result of the multiplication is always stored in higher byte, in higher byte and in lower byte. Okay. The higher byte is always stored in register B, and the lower byte is always stored in register. Okay, that means after 65H into 32H, we get register A equal to register A equal to BA and register B equal to 30. Okay, so we can write algorithm for this. Our first step is first load 65H into register A or accumulator. Our second step is load 32H into register. Now the third step is multiplication. Now the result of the multiplication is very large, hence store the higher byte, higher byte, that means register B into the memory location 54H. Similarly, load the lower byte, that means register A into 55H memory location. Okay. Now let's write instruction for this program. Let's see once again. We want to perform 65H into 32H. The result of this multiplication is very large, 13BAH. So this result is divided into two parts, higher byte and lower byte. In multiplication, the higher byte is always stored in register B and lower byte is always stored in register A. The algorithm is very simple. Load 65H into accumulator, load 32H into register B, then multiplication. We can use for this multiplication the mnemonic MUL multiplication. Okay, then move the content of register B and register A to this memory location 54H and 55H. Let's write the program. First of all, assign them as a comments. Remove this instead. Okay, we give org00H. Then our first instruction is move A comma 65H immediate 65H. Then second instruction is move B comma immediate 32H. Okay, then multiply it with MUL A comma B. Then move the result into the different memory locations. Move 54H comma B. Similarly, move 55H comma A, and last end step. Okay, then click to the save or enter Control S. Then go to the project, select build target. Here, one error. Okay, here we made one mistake. MUL A comma B. It is A B. Okay, then save it again. Go to the project, select build target. Okay, we get zero error, zero warning. Again, go to the project, select rebuild all targets. Warning. That means our program is ready to execute. Now go to the debug, select start stop debug session. We want to perform the step by step execution. Hence use this icon. After this instruction move A comma hash 65H. Accumulator will contain 65H. That means here we get 65H. Okay. After next instruction B will contain 32H. Here we get 32H. Okay, Here, this instruction will perform multiplication of A and B, and the result will be in two parts, register A and register B. Let's see here. We can see here register A will contain BA and register B will contain 13. Now move this content of B into the 54H. This is 51, sorry, this is 50, 51, 52, 53 and 54. At this location we get 13H. That means the content of register B. After this instruction we get 55, we get BA into the 55H location. That means here we get BA. Okay. And end. I hope you all understand the simple assembly language program for the multiplication. Now let's see the assembly language program for division. Our next program is assembly language program for division. Okay. First of all, assign this instruction as comment, remove and statement. Now, first of all, let's see the algorithm for the division for division. If we want to perform the division of 86H divided by 14H, then the result of the division is already in two parts. That means in quotient, and second is remainder. Okay. After this division, we get quotient as a 06H and remainder as a 0EH. Now, this result is also very large. Hence, these are in two parts. These two parts is saved into the register A and register B. The result of the division is quotient, and quotient is always stored in register A. Quotient is always stored in register A and remainder is always stored in register B. Okay, I hope you all understand this content, this concept. If we perform 86H divided by 14H, then the result will be in two parts, quotient and remainder. The quotient is always stored in register A and the remainder is always stored in register B. This division gives us quotient as 06H. That means register A will contain 06H and register B will contain remainder 0EH. Now let's see algorithm for this program. Algorithm for this program. Our first step is that load 86H into the accumulator register or register A. Then our second step is that load 14H into the B register. Then our third step is that perform division. For this division we can use simply div. Then fourth step is that the result is in two part, quotient Quotient is always stored in register A, and second is remainder. The remainder is always stored in register B. Now move this result to the memory location. Quotient will be stored in 57H memory location, and remainder will be stored in 58H memory location. Okay. Now let's see once again, if we want to perform division of two data bytes, for example 86H divided by 14H, the result will be generated into two parts, quotient and remainder. The quotient is always stored in register A and remainder is always stored in register B. The algorithm for this division is load first data byte into the register A, that means load 86H into register. Load second data bytes, that means 14H into the register B. Then perform division. The result is in two parts, quotient, that means register A will register A and remainder is stored in register B. Move this result to the memory location 57H and 58H. Okay. Now let write the instructions for this division. Our first instruction is that move A comma first data byte is 86H. Now the next instruction is move B comma the second data byte is 14H. Then perform division div AB. Okay. In multiplication AB, and in division div A. No need to give comma between A and B. Okay. Now move the result into the memory location. See B equal to 50. Move 57H comma A. Then move 58H comma B. Then end step. Okay. Now save it. Then go to the project. Again build target. Here we get again go to the project and select rebuild all target and warning. That means our program is ready to execute. So go to the debug tab, select start stop debug. Okay. The output window will be appear. Here we want to perform the step by step execution. Let's see. Now A contains 00, B will contain B has 00H. After this instruction, move A comma hash 86H. 86H will be loaded into the accumulator. Okay. After second instruction, move B comma 14H. 14H will be loaded into the register B. Here we get 14H. Okay. Then division of AB. We know that the quotient is 06H, hence accumulator will contain 06H, and the remainder is 0EH. That means B contains 0EH. Let's see. A will contain 06H and B, that means remainder will contain 0EH. Now move this result into the memory location 57H. A will move into 57H. This is 50, 51, 52, 53, 54, 55, 56, 57. At this location we get 06. Okay. Now at this location 58H we get 0E. I hope you all understand the simple program for the division. Now let's see the combined program. of addition, subtraction, multiplication, and division. So remove this double slash, that means comments. Okay. This is our final program for addition, subtraction, multiplication, and division. Let's see. First of all, save it or enter Control S. Then go to the project, select build target. We get zero error, zero project. Select rebuild all target files. We want to run it, hence go to the debug and start stop the debug. Okay. The output window will be appear. We get the memory 1, and we are going to store the result into 50H memory location. Hence we type here D colon 50H. Okay. Let's see once again. Go to the memory, select memory 1. Again go to the memory, select 1, type D colon 50H and simply enter it. We get the memory location 50H, 51H, 52H, 53H, and so on. Okay. Now let's see step by step execution. Our first instruction is that org00H. That means our program is started from the memory location 0H. Then next instruction is move a comma hash 42H. That means 42H will be loaded into the accumulator. Now currently accumulator has the value 00H. After this execution, we get accumulator is equal to 42H. Step by step execution, click this icon. We get 42H. After this instruction, register B will contain 12H. That means here we get 12H. Then addition of A with B. The result of the addition will be stored into the accumulator register. We know that the result of the addition is 54H. That means A will contain 54H. Okay. Now move this 54H result into the 50H memory location. That means at this place we get 54H. Let's see. Okay. 54H. I hope you all understand this execution of the program. Now the next step is move a comma hash 42H. That means 42H will be loaded into the accumulator. Here we get 42H. Let's see. Then move B comma hash 12H. That means 12H is loaded into the register B. It has already 12H. Let's see. 12H. Now the subtraction will happen on A and B. The result of the subtraction is 30H and it is stored into the accumulator register. Hence we get here 30H. Okay. Move this result to the 52H memory location. This is 50, 51, 52. At this place we get 30H. Now next program is program for multiplication. We want to perform the multiplication of 65H and 32H. The result is too large, hence it is stored in register A and register B. The function of register B is that it is always used with register A during each multiplication and division operation. During each multiplication operation, register B will contain higher byte, and during each division operation, register B will contain the remainder. Let's see. After execution of this instruction, move A comma 65H. A will contain 65H. That means here we get 65H. Okay. Then after this instruction, we get B equal to 32H. Here we get 32H. Okay. Now multiplication of A and B. We get result into A in A and B. The result is 13BA. So register B will contain higher byte 13 and BA is lower byte. It is stored into register A. Move register B to the 54H location. This is 50, 51, 52, 53, 54, 53, 54. At this location we get 13. and at next location we get A, that means BA. Okay. Now our next program is program for division. We want to perform division of 86H and 14H. So move first data byte into the register A. That means register A will contain 86H. At this place we get 86H. Now next instruction is that move B comma hash 14H. After this instruction B will contain 14H. Now division of A and B, and the result is in the form of quotient and remainder. The quotient is 06H and it will stored in register A, and the remainder is 0EH, it will stored in register B. Let's see. The quotient is 06EH and it is stored in register A. The remainder is 0EH and it is stored in register B. Move this result to this memory location. Move A to the 57H. We get here a 06H move to the 57H. The next instruction is that move B at the location 58H. That means at this place we get 0E. B will contain 0E, and at this location we get 0EH. Okay. This is our simple program, simple assembly language program for addition, subtraction, multiplication, and division. I hope you all understand how it will run on the Keil software, the steps of the Keil software, and how to see the step-by-step execution of the result in this Keil software. I hope you all understand this practical and able to run on your own desktop or own PC. If you understand this concept or you understand how to run this practical, then share it with your friends. Thank you.